Hi viewers, today I am discussing kinematics part. So in kinematics, in last class I discussed oblique projection. Oblique projection. Oblique projection is nothing but the body is projecting. The body we project with some velocity. The velocity direction is making angle with horizontal. So that is the horizontal oblique projection. So this is the x-axis. The body is projected, the velocity u or whatever it is u. So the body goes like this. We are projecting with some angle that is making with the horizontal. This is oblique projection of the body. Oblique projection of the body. This is the y-axis. This is the x-axis. So the path of the body will be like this. This is x-axis. It will go some height, maximum height, and finally reach the ground. Finally reach to the ground. So like this, the body is projecting with initial velocity. With some initial velocity, the velocity direction is making angle theta with x-axis. Then we can say the body is projected obliquely. Obliquely is nothing but making some theta with x-axis. So this is the information of oblique projection. So last class I discussed, but I want to discuss some more. So I am explaining one more time. So this will be x-axis, this will be y-axis. This will be x-axis, y-axis. So we are projected with velocity u. So the velocity is vector quantity. Velocity is a vector quantity. So the vector quantity is making angle with horizontal, that is with x-axis. So the velocity has two components here. One is ux, the velocity component along x-axis. One more velocity component along y-axis. So the body is projected like this. It goes some height, that means maximum height it will reach. After that it will fall on the ground. So now we have the kinematic equations. V equal to u plus ct is the kinematic equation 1. S equal to ut plus of at square. So we have one more, v square minus u square equal to 2as. Just we apply these equations in this oblique projection. We will get some kinematic equation for the condition is oblique projection. So the conditions, this is a linear motion kinematic equation. So by applying these conditions, these equations, we will get oblique projected body kinematic equation. That means final velocity of the body can be the displacement covered by the body along x-axis, along y-axis. So these relations we will get. So from this, next, here ux is the velocity vector is making with horizontal theta, that become ux is nothing but u cos theta. The cos theta we take always, the theta is making with x-axis. The theta, the angle is making, is it with the horizontal, is it with the vertical? If it is making with the horizontal, the cos theta term will come to in the horizontal, ux. So here this will become u sin. So I am applying here v equal to u plus at. So throughout the journey, that means the body, the projected body starts here, it goes up maximum height, then finally reach to the ground. So it is along x-axis, along y-axis. So velocity along y-axis, velocity along y-axis. velocity, initial velocity along y-axis, acceleration along y-axis. So for this body, the oblique projected body, always acceleration is equal to minus c. Acceleration is equal to minus c. Just I am applying here. After time t, so for example, after time t, the body starts here, it travels. After time t, the velocity of the body, initially the body has u by velocity, then the change the body at after time t equal to vy equal to uy is nothing but u sin theta, ay equal to minus gt. So this will become the velocity component after time t in vertical along y-axis. So what about along x-axis? Ux plus ax into t. So the acceleration is in the downward direction. That's why acceleration, that is along y-axis, vertical direction, that is equal to minus z. Along x-axis it has no acceleration. So Vx equal to velocity along x-axis after time t. So here, so Vx and Vy, two components will be there. This is the point after time t, starts here, after time it reaches here. At this point, for example point A, the velocity along y-axis, this will become along x-axis. So I already calculated Vy, now I am calculating Vx. Ux is nothing but u cos theta, then this will become 0. So u cos theta is along x-axis. So horizontally the velocity component is u cos theta, and vertical direction u sin theta minus gt. Already I calculated these things, so now I am repeating. Next, you just write it when I am saying. Next, see after time t, after time t, the displacement covered along x-axis, along y-axis. Displacement covered along x-axis and y-axis. For example, we have the equation s equal to ut plus half at square. Along x-axis, ux t plus half ax into t square. See the displacement covered by the projected body, obliquely projected body. What is the displacement? For that one, we can get like this. Displacement along x-axis, ux is nothing but u cos theta into, so this will become u cos theta into t. This is the time after time t. For example, I take a t. The body is here. After time, the body has gone to here. So this horizontally displacement, this will become sx. This will become s. Is it? Now this is also you just write. Well, displacement along x-axis. What about displacement along y-axis? Displacement along y-axis. Simply you change the equation. S equal, we have the equation, fundamental equation, this one. Sy equal to uy into t plus half ay into t square. See here, uy is nothing but u sin theta into t, half ay is nothing but that is equal to minus z. So this will become displacement along the vertical. Displacement along the vertical direction. What is the displacement? Sy equal to u sin theta of t minus half gt square. So like this, we are calculating after time the velocities after the, what is the velocity after time t? Obliquely projected body. The displacement along the x-axis. What is the displacement along the x-axis after time t? What is the displacement after the velocity after time t along vertical direction? These we calculated here. So see, my question is, My question is, see the equation of, not equation, the path of the body. The path of the body, actually the body starts here, the final position of this body. See, it starts on the x-axis, finally reach to the x-axis only. So what happens? The displacement covered along x-axis. The displacement covered along x-axis. There is no displacement along y-axis. Why? Because see, initial position is this one, final position is this one. So both initial and final position on the same x-axis. So the vertical displacement will be zero. Vertical displacement will be zero. So vertical, we have the equation ut plus half at square. So vertical displacement throughout the journey. So after time, I am taking the time taken, the total journey is capital D. If I take the total time taken by the obliquely projected body, the traveling time, total time will be T, capital T, then U into, say Uy into T plus half Ay into T square. See, the obliquely projected body, vertical displacement will be zero because it starts on the x-axis and final position is also in the on the x-axis. Final position is also on the x-axis. That's why there is no displacement along the vertical. Initial and final position on the x-axis only. With respect to origin, both are in the same on x-axis. That's why you just put this one. U sin theta, you just use U sin theta U into T minus half Ay is nothing but minus Z square. So just use U sin theta into T equal to half Gt square. Dt gets cancelled. You will get 2U sin theta by G. So this is, we got T equal to 2U sin theta by G. 2U sin theta by G. That means I use here T equal to capital A, that is total time for journey, total time for its journey. So I can use this is total time flight, time of flight. What is this one? Time of flight. Flight means the flight is which is in the air. See the body, the projected body, how much time it is in the air, that is equal to time of flight. The total time of flight is equal to U sin theta by. This is also important, the equation. Just what I am doing here, just I am applying kinematic equation with respect to this obliquely projected. That's it. So to use sin theta by, that is time of flight. So you just copy it. I draw equation for time of flight. Time of flight. Okay. Next, we check. Just copy it. How I am calculating. See, we got now time of flight, that is it visible? Okay, I will write here. T equal to 2U sin theta by G. This is time of flight, the total time taken by the body to cover all the displacement. Now range, I am giving range. See, range is R. So what is the range here? What is the range? So range means the body projected from here. We projected from here the body. See, we projected, so making angle with horizontal, we projected like this. Finally it reached on the x-axis. It falls on the x-axis. So this horizontally displacement covered by the projected body is nothing but range of the body. Range of the horizontally displacement covered by this body. So that means, so Sx equal to, so Sx is so the subscript x means the displacement covered by the body along the x-axis. We have the equation s equal to ut plus half at square. So displacement along x-axis ux into t plus half ax into t square. So here ux is nothing but u cos theta. See the time here for the range means this is the initial position, this is the final position. The total journey, the time taken by the body is time of flight. The time taken by the body is nothing but time of flight. So u cos theta into t. See ax will be 0, so this is a u cos theta. So just you substitute total time of flight, that is equal to u sin theta, by g. So what u square 2 sin theta cos theta by g. So we can write this one sx equal to u square sin 2 theta by g. U square sin 2 theta by g. So sx is nothing but displacement along x-axis, that is nothing but range of the ball. So I calculated one more formula here, r equal to sx equal to u square sin 2 theta by g. So simply we can write r equal to u square sin 2 theta by g. Okay, see how I calculated here. Simple, I used kinematic equation for the situations apply. What are the conditions I applied here? Ay equal to minus z, ax equal to 0. So I have the kinematic equation s equal to ut plus half at square. Sx is nothing but displacement along x-axis, that is nothing but range of the body. So ux into half ax into t square. Ux is nothing but u cos theta into total time of flight. I already calculated time of flight value, so I substituted here. Finally I got range equal to u square sin 2 theta by g. U square sin 2 theta by g. So like this we calculated. Just you copy it first. You copy it. Okay, then one more one more formula we use from this. So here I am drawing same graph. This will be x-axis, this will be y-axis. So we projected a body with velocity, initial velocity u. So this is obliquely projected body diagram. So obliquely projected body, it gains some maximum height, then falls the height to the 0. So it starts here and falls on the x-axis only. So this is a velocity component. The velocity component has horizontal component ux, vertical component uy. So here ux equal to u cos theta, uy equal to u sin theta. Is split into two components. Every vector we can split into two components. Okay. See, this is u cos theta and u sin theta. So what happens here, after time at maximum height, this is a maximum height. So what happens, vector v, the final velocity, if it is v, so this vector has the velocity direction will be like this is the tangential. So v is nothing but vx, that is nothing but ux. So Vy component will be, vertical component of velocity will be 0. Horizontal components will be equal to u cos theta. So this velocity has only horizontal component, that is equal to u cos theta. Vertical component will be 0. So we can apply simple equation v equal to u plus at. So Vy equal to uy plus ay into t. So after time t, it reached maximum height. So at maximum height Vy equal to 0, uy is nothing but u sin theta, vertical component of velocity, ay equal to gt. So what happens here? T equal to u sin theta by g. We just copy it, this one. Just copy it. After that, just message me, it is okay. So what I did here, I splitted velocity component into two velocity vector in two components, ux and uy. Along x-axis it will be u cos theta, along y-axis u sin theta. At maximum height, it has only the velocity component, it has only horizontal component, it is there, vertical component it will be 0. So vx is nothing but ux equal to u cos theta. So what happens, we just I applied vertically, what is the velocity vertical direction, v by uy equal to ay into t, u sin theta minus gt equal to t equal to u sin theta by g. The time taken to reach maximum height, how much time taken to reach maximum height, that is equal to u sin theta by g, u sin theta by g. Just what is the t here, the time taken to reach maximum height. So I am going to calculate maximum height. This is also one more important concept in oblique projection. Maximum height, that is capital H. So maximum height. So how do we calculate? So S equal to v square minus u square equal to 2as. We can use this equation. Can you calculate this one? You just try it. Can you calculate by using v square minus u square equal to as? See, I can use here only vertical direction velocity only. So to use just vy, uy, ay. Just try it first. Can you draw? Vy square minus uy square 2ay. All are in vertical. Did you? Okay, I am trying here. Simply, they are using third equation, kinematic equation, that is v square minus u square equal to as. So I am calculating the maximum height in vertical in the along the y direction. That's why I used subscript vy uy to ay. So vy square minus uy square equal to 2ay. See, I am using instead of displacement h max along vertical direction. So here Vy at maximum height, this component will be 0. Uy, so vertical component of velocity in the y direction, that is u sin theta whole square to Ay is nothing but minus g h max. So I can derive for h max. So minus gets cancelled. U square sin square theta by 2g. U square sin square theta by d. 2g. This is the maximum height reached in obliquely projected body. If the body is projected obliquely, how much height it reached in the whole journey. So this is the maximum height covered by the body, u square sin square theta by 2g. So this is h max, u square sin square theta by 2g. So these three equations I calculated today. See, first one is equal to what I calculated first, time of flight flight, that is capital T, equal to 2u sine theta by g. Range is nothing but Sx. So displacement along x-axis, u square sine 2 theta by g. So next, Hmax is nothing but the maximum displacement along vertical. So that is equal to u square sine square theta by 2g. So these three formulas I derived. This is very useful formulas. See what is there? First, time of flight, the total time taken by the body in whole journey. This is the displacement along x-axis, that is nothing but range. Hmax is nothing but the projected body cover displacement along vertical direction, that is in the y direction. What is the maximum height reached by the body? That is u square sine square theta by g. So these three equations you should remember. I explain how do we generate, how do we that means how do we produce these formulas, how do we derive these formulas. You just practice it. I use the condition. So what I use conditions here, obliquely projected body. Simply I am repeating one more time. You just remember, easy to draw. You can draw easily like this. X-axis, y-axis. We projected a body with velocity u. This is vector quantity. That's why we can split into two components: ux along x-axis, uy along y-axis. Ux is nothing but u cos theta. Uy velocity component along vertical, that is u sin theta. So the body projected like this. This vector always tangential to the path. Tangential to the path. The vector velocity direction. So this is the angle theta. Is it? So this will become h max. So this total path, the total displacement along the x-axis is nothing but Sx. This is nothing but range. So next, maximum height. The maximum height Vy, velocity component along y direction, along vertical, that is equal to 0. What about Vx? U cos theta, that is there is no change in Vx. So here the velocity direction will be like this. So Vx, there is no Vy. Vy it is there, but that is equal to 0 component. So these things. So for this one, the total time, that is time of flight, 2u sin theta by g. What about range? U square sin 2 theta by g. What about h max? U square sin square theta by 2. So these things I want to give today. If you understand well, you can message me yes. We will see tomorrow some conditions. Okay, just copy it and practice it. First of all, you have to practice. What is Vy? What is Sy? What is Ay? There is no Ax. Ax equal to 0. The conditions here it is Ax equal to 0. Where acceleration along x-axis, there is no acceleration along x-axis. Only the acceleration along y-axis. See, that is equal to also Ay equal to minus. You should take Sx, Sy we calculated. Everything we calculated. So this is a simple concept, obliquely projected body. Obliquely projected body. Okay, thank you. Tomorrow we will see some more conditions regarding to obliquely projected body. Thank you.